So welcome on this session, last session of today. Hope you had an amazing day. We'll talk about the Swiss Army knife of cloud native networking. First of all, the obligatory slide, the WebEx app. You can use the WebEx app to reach out for further questions, to interact, to give your review of the session. So please feel free to do that. And also, we have a Slido session set up because we have some interactive questions. If you want to participate, please join slido.com and enter the code or use the QR code to participate. Now, you also seen this booklet, so for anyone staying, please stay. I'm happy to share a nice little book about network policies in enterprise environments, how you to adopt network policies using our products, but also using our UI, and also guiding you with a strategy how you can adopt them iteratively and use our tools and monitoring to actually confirm that the policies are applied in your environment. So stay around and happy to share the booklets as well. Now, let's get started. My name is Raymond de Jong. I'm Field CTO EMEA for ISO Valent at Cisco. Already 4 years at ISO Valent, now almost 2 years with Cisco. We got acquired a bit more than 1.5 years ago. So happy to be at Cisco, and we provide cloud-native networking, observability, and security solutions for Kubernetes, amongst other integrations as well, which we don't cover today. I'm happy to share I'm living in Switzerland. That's also why I have chosen the Swiss Army knife. I actually live very close to the factory where they produce them, so I think that's fitting. Some of my colleagues call me the free ambassador for Switzerland tourism because I absolutely love hiking, biking, skiing, and so forth. So if you need tips, I'm happy to give you those. Does it work? Almost. Okay, I'll manage the other way. Packed agenda. About an hour, we'll first introduce eBPF and Cilium, and then look at the ISO Valent platform, and we'll dive into the ISO Valent networking for Kubernetes solution. Then we go through a couple of features on our Swiss Army knife, how it works, and we will conclude with a demo, where we bring it all back and show it in a live environment, and show how you can set up, for example, load balancing, gateway API, with BGP to automatically advertise IP addresses on the network, and also in a multi-tenant way. So I'll show you some examples how you can achieve that. How many of you know eBPF? Quite a few, okay, good. So eBPF is the powerful engine in our car, and we are co-contributors of eBPF. We have 2 open source projects we started about 10 years ago, which is Cilium, and part of Cilium is Tetragon. And we also have an enterprise platform for running and supporting our customers at scale. And that has obviously more features in terms of high availability, observability, also compliancy features and such. So if you're interested in that, we're happy to help you there. So I was too early with my question, so how familiar are you with eBPF? Just a couple ones. So I'll quickly continue. We like to say eBPF is like JavaScript in the browser. It makes your browser, or it makes the kernel programmable in a dynamic way, and allows us to run code without changing the kernel. That allows us as well to innovate on the network, or to allow features to be run in kernel space at super speeds at scale. It's also safe. You cannot just run anything randomly in the kernel. There are constraints. There are just-in-time verifiers to make sure what you run in the kernel is actually allowed, doesn't have loops, doesn't have memory leaks, and so forth. So think about it, speed with safety. And that's the core technology we use throughout our product. eBPF programs are triggered on kernel events. So think about your Kubernetes nodes or Linux machines. Everything goes through the kernel. This actually also applies for Nexus and smart switches and such. So once, for example, a network interface sends a packet on the wire, this is a kernel event. Or once a container on Kubernetes wants to send or open a connection, this is a kernel event. And we can do things with that. And how we use it is to attach eBPF programs to observe, to monitor, or to secure traffic from a given source to a given destination. Keep in mind that you don't have to be an expert on eBPF. You just configure isovaliant networking. You enable features, you enable network policies, and under the hood, the magic with eBPF happens. And this is where I stop with the technical eBPF details, because this is all you have to know. So our platform is built on the foundation of eBPF. Cilium provides the networking, observability, and security features. And Tetragon provides runtime security features, things like processes, file integrity monitoring, making sure that no one becomes root without having permissions. We're focused today on the networking for Kubernetes solution, but we also have mesh networking for service mesh. We'll cover parts of that, but also a load balancer product and a runtime security capabilities. The load balancer is included in the isovaliant networking for Kubernetes as basic load balancer, and you use it for gateway API and ingress, which we'll all show in the demo. But we also have an advanced load balancer, which allows you to run load balancing in a cluster or standalone as a VM in vSphere, and that covers things like all the algorithms, authentication, health checks, and so forth. So isovaliant platform is a true Swiss Army knife for cloud-native networking. You can combine all kinds of different features and adapt them to your requirements and needs, and we'll cover those in a lot of slides and the demo as well. So what are the topics you are most interested about for today? So is that BGP, is that layer 2 announcements, LBIPAM, gateway API, network policies, or egress gateway? Egress gateway, okay. Network policies, gateway API, okay. I didn't expect that to be that high. Good. Network policies, cool. All right, we'll cover them all. On the network policies, I do the introduction. So for the persons wanting to know the deep level capabilities, the book is definitely a takeaway here. And let's move on, thank you. Let's start with the easiest one, layer 2 announcements. This is super useful for small environments to spin up a Kubernetes environment and to make sure that things like load balancer services or egress gateways are discoverable, routable on the network without any configuration. Another option is obviously static routing, but this is the easiest way for test environments to start with, right? And this allows you to, Cilium allows Cilium to respond to ARP requests, right? Who has this IP? So as soon as you create a load balancer service to be able to receive traffic, Cilium will respond to ARP queries from the network to be able to reach that application. Let's say your developer team starts testing, running an application on Kubernetes, and on the network you want to make sure this is reachable, and enabling layer 2 announcements will work very easily. Obviously, if you move to production, this is not the best option. You rely on the gracious ARP to time out on failover events and so forth, and you cannot do any traffic engineering. But it's a great start for small environments. Everything in isovaliant networking works with CRDs, declarative APIs, so custom resource definitions. So in this example, you would select what kind of service you want to advertise. This would be any load balancer with a certain label, in this case blue. And you would select which nodes will respond. So if you have specific nodes you want to have for receiving traffic, you can configure that this way. And then you will specify what kind of services you want to expose, whether it be pod IPs, external IPs, or load balancer IPs. Now let's move on to the real deal, BGP. Cilium supports BGP out of the box, and we have different use cases and different challenges using BGP in cloud-native environments. Use cases obviously is determining ingress and egress traffic using load balancers, egress gateway, gateway API, and so forth. Obviously with BGP you can automate the network, and I will show in the demo how that actually works in practice by using other components in conjunction with BGP. Obviously, availability, having multiple nodes across racks, you can define rules how traffic should fail over. You potentially can enable equal cost multipathing, so all the nodes across your racks or after a specific top of rack can receive traffic for high throughput, high performance networking. And there are also ways to allocate specific nodes to be able to receive that. So you can design specific topologies, especially in bigger environments, to adapt for network traffic coming ingress. Obviously, recoverability, if a node fails and recovers, BGP will be established again and can receive traffic after it's established. And you can do traffic engineering. You can decide how traffic should be routed. In one example in a demo, I will show how you can use different subnets so you can program your network to route those traffic differently to maybe an external firewall or to the internet or to specific subnets on your network. And the challenges here are multi-tenancy, how to make sure that you can distinguish which app or which team is using a specific IP or prefix. And obviously security for BGP, optimizing traffic, especially at scale, and having that scalability across multiple racks. There can be a challenge, but I will show how you can actually work with that. Now, what do you think from your experience? I'm not sure if you already run Kubernetes at scale or running BGP in conjunction with Kubernetes. What do you think would be a challenge? Scale. Yeah, multi-tenancy. Yes, multi-tenancy is definitely, we see it as a challenge in our customer environments as well, because you have dedicated clusters running different applications, especially in mission critical and production environments. You need to ensure that specific applications are routed throughout the network, and especially with egress connectivity, you want to ensure that only specific workloads can connect to, let's say, your critical database or your object storage or a resourcing cloud. So we'll dive into the capabilities we have there. I don't think I need to introduce BGP, but for the people who are not aware of BGP, obviously it's a dynamic routing protocol, uses TCP port 179. Routers can exchange routing information. For example, router A can ask to router B, hey, do you have this IP? Router B can announce, yeah, I have that IP. So obviously that's done through a peering session. And obviously, as well with our product, a Cilium router can build multiple BGP sessions with different upstream routers as well. So all the things you can expect. Now, Cilium has BGP included. We have a BGP control plane v2. We optimized the BGP capabilities and how you can configure and manage them. And it's done for custom resource definitions, but we'll focus mostly on the BGP cluster config, which actually configures virtual BGP routers. A peer config, which contains common settings for multiple BGP routers, such as passwords and such. And the actual advertisements, where you specify what you want to advertise. And they are all referenced by labels, so cluster configs are referenced by BGP instances, peers are referenced through the BGP peer config, and obviously the advertisements show things like a pod IP or pod CIDR or service of type load balancer. We'll dive in a bit further and in the demo as well. We support halt, keep alive timers, graceful restarts, BFD. We just introduced aggregation, obviously very useful if you have a bigger prefixes and you want to avoid BGP updates and stuff. Multi-hop communities, BFD for high performance, high available environments, and also operational tooling, and I will show that in the demo. How it works is, first of all, you start with a cluster configuration. You would specify which nodes are actually are supposed to set up BGP sessions. So in this example, I have added labels to specific nodes, in this case rack 0. And then I define BGP instances. In this case, I give it a local 6500 name, and I define an autonomous system number. Then I define the peers. So in this case, one peer, same ASN, so we're talking iBGP here. A peer address, in this case an IPv6 address, and then you reference the Cilium peer resource it should use for the additional settings. And this brings us to the next one. And a Cilium BGP peer config is typical a configuration which spans across multiple BGP speakers. Things like passwords, retries, timers, and that kind of stuff. So in this case, we specify timers, we specify an MD5 password. In this case, graceful restart is enabled. And this will be applied through all the BGP instances on your nodes. And the most important part is also specifying what services should be advertised. This is the label where the peer reference in the previous configuration is using to make sure that those nodes or those BGP speakers advertise IP addresses I specify in this configuration. And then I specify what kind of addresses I want to advertise. Again, you can do pod IPs, external IPs, cluster IPs, node IPs. And in this case, I want cluster, external, and load balancer IPs to be advertised. And then you can use kinds of expressions, so match specific labels, expressions, or specific namespaces, and I will show examples later. How this actually works, sorry, I'm going a bit too fast, is once you create a load balancer, and this load balancer has a given value of blue, that will be selected to be advertised. I will bring this back in the demo and you can see it in practice. Another crucial component to get this multi-tenancy networking going is having an IP address management tool. And our product has that included, and that allows you to define resources for tenants or applications and to allocate IP prefixes to them. That again allows to be tied to the BGP and the load balancer configuration. So you can say yellow IP pool is with label yellow will be used for yellow load balancers. And our operator makes sure that as soon that load balancer with that label is created, it picks an IP from that pool and advertises it through BGP. And then you want to additionally have layer 7 capabilities. And again, Isovalent networking and Cilium open source support Gateway API. Gateway API is part of the Kubernetes ecosystem, and we support already all those capabilities. And what it allows you to do is to define rules for different personas, how that traffic should be dealt with. And typically, an infrastructure provider defines the gateway class. And in our case, this is very simple. This is a Cilium gateway. And then you have the option as a cluster operator to define one or more gateways. In a given cluster, if you want, you can have a shared gateway. We see that typically being used in cloud because if you create a gateway in cloud, it will allocate an IPv4 IP. It will use a load balancer. In terms of cost, you want to share those resources. But maybe you want to have a specific gateway per tenant or specific gateway per application, and in turn have a specific IP or IP pool per gateway and tenant. And that's done through a gateway resource. And then the power of Gateway API is that application developers can define rules, how layer 7 traffic should be dealt with, what paths should be forwarded, what percentages of traffic I want to forward to service A or service B. And they can attach that to a given gateway. And it also has this role separation where the infrastructure team or the cluster operator can make sure that the gateway are configured, BGP is set up, and independently application developer teams can attach routes to that, HTTP routes, with the right filters. Capabilities are obviously for an application team super powerful. You can do rolling deployments, percentage-based routing, you can do circuit breaking, you can do live testing of new services in production without actually hitting the production traffic. You can do canary rollouts and blue-green rollouts. So those are typical DevOps means of running applications in Kubernetes and to gradually introduce a new service or a new version of your app in production. Added benefits is with our product you have the scalability. By using eBPF, the performance is there. Depending how many nodes you have, you can scale up and scale out. And there's also the golden signals. What that means is that you can have metrics out of the box without any instrumentation on your apps. Things like HTTP return codes, duration of a request, what policy hit it, or what layer 7 filter is applied. Those are available without proxies and without additional configuration out of the box. There's a couple of more features. I will not repeat them every one of them, but the most important for today is this infrastructure labels and annotation one, because that allows you to define and design this multi-tenant networking. I will show in a demo later as well. In terms of performance, the local external traffic policy is a nice one, because this is a setting where you can ensure that once traffic hits a node, it will keep it in that node. It will not do another hop. So it will only load balance to endpoints on that given node, because by default, Kubernetes will load balance to any endpoint across the cluster. Can be an optimization setting. The downside is that you can also have a bit of a disbalance. So let's say a given node has 10 endpoints and another node have 1. They all will load balance to their respective nodes endpoints. So the node with 10 endpoints is more busy than the node with 1 endpoint. HTTP routes, TLS routes, gRPC routes are supported. So HTTP routes are the most common. Layer 7 path, return codes, all that stuff is included. TLS routes can be interesting for TLS pass-through to make sure that TLS is not terminated on the gateway, but instead on the application itself. And gRPC routes for specific gRPC route purposes. We're also contributing to the Gateway API project, and hopefully we'll also support UDP routes soon. That can also be interesting. Moving back to this gateway infrastructure labels, and this is important in the demo to understand how this works. So for example, I specify a gateway blue, and adding this spec infrastructure labels colors will make sure that the load balancer being created automatically inherits these labels. That in turn will make the load balancer IPAM operator see that it needs to allocate IPs for this blue load balancer. As you can see here, this is the automatically created load balancer in Cilium. It has those labels and it will be useful for having the IP allocation in the load balancer IPs. Now we've discussed ingress, but we also need to think about egress traffic. Typically, applications in Kubernetes are not consistent by themselves. They need data, resources externally, whether it be images, videos in case of streaming, or whether it be certain models from an AI perspective, or maybe a service or database with identities and storage for an application to work. In our customer's environment, this is typical, a very secure endpoint, a very secure destination. So you only want to make sure that you can have a specific IP being used or set of IPs being used to be able to reach this destination. So let's say behind this firewall on the right, I have a database and I want to make sure that only specific nodes with a specific IP are allowed from a Kubernetes cluster point of view to reach that destination. And that will be configured through gateway API, egress gateway resources. So for example, I can define rules for my pod on the left to be source netted to specific IPs to reaching that database. And note it can be active and active standby. So I can define a group of nodes for egress connectivity, and I can configure them as active or active standby. That means that you can obviously have more performance and availability as well. And we see some customers defining groups of gateways for pure egress connectivity. So those gateways are not running pods themselves. They just forward packets for egress connectivity to a given destination. Especially in cloud and streaming, media and radio and telco environments, this is very important. Obviously availability as well, so they define a group of nodes, part of the cluster, dedicated to egress. This is defined through label selectors and also destination CIDR. So in this simple example, I have 000/0 as a destination as to be a rule for this policy to apply. And I also do a pod selector. So in this case, I'm matching for a given pod name in a given namespace. And this can be very flexible. It can be namespace-based, label-based, very specific. And you can also have multiple destinations with multiple selectors. So you can make this as deep or as specific as required. We also support a availability zone affinity. So especially in cloud environments where you want to keep in the availability zone, you can add labels and annotations to your nodes. So it will egress locally. This is again to save cost and to reduce latency. And then you would specify what nodes should be used. Again, you can use labels being added to nodes, but you can also specifically mention IPs or interfaces on that given node. So a condition we need to have is that IP needs to be configured. And if you want to use multiple nodes, you would need to configure multiple IPs, and we soon release a floating IP to be supported as well, so to dynamically fail over traffic with multiple nodes. And yes, the topology awareness is here as well. So this is also the zone being used for this availability zone affinity. Then on the BGP side, you can configure a BGP advertisement, and you can define rules what egress gateway, with selectors, should be advertised with BGP to be able to route this on the network. That's also very important, otherwise it won't find the route back. So having that configured in this way makes it dynamically possible as well. Moving on to network policies briefly. Combined with egress gateway, you can use network policies to define rules east-west within your cluster. For example, that traffic in a namespace is allowed, but not by default externally. You can define rules for allowing external traffic using egress gateway in combination with network policies to allow traffic to an external destination on a given port. Before I move on, I need to introduce the identity-aware security model. You saw a couple of times that we use labels and metadata throughout, and under the hood that means that we use an identity. So each unique set of labels or each unique set of metadata gets an identity associated with. And we use this throughout Kubernetes and throughout our solution for observability and security use cases. The reason why is in Kubernetes, IP addresses are ephemeral, right? They come, they go. One day you have 10 pods with random IPs, the next you have hundreds with different IPs. So troubleshooting and monitoring traffic using IPs in Kubernetes is hopeless. It's unachievable. So therefore we assign identities. That means that if I have 10 pods with a certain label, they share that same metadata, and therefore in our world they have the same identity. An external destination like an FQDN or a CIDR block or an IP also has an identity, and we use that for monitoring, for metrics, and for network policies under the hood as well. To give you a simple example, for example, we have 4 front-end pods in a front-end deployment. They all have the front-end label, and therefore we assign all those 4 pods with the same identity. In this case, 10, just a random number. Then we have a backend service consisting of 2 pods in this case. They have a different label, different set of metadata, and therefore we assign a unique identity for those endpoints as well. Let's say on a Black Friday event, I need hundreds of front ends, right? That can happen. Given they have the same set of labels, they will all share the same identity. And this identity is used under the hood in eBPF. Actually in IP headers, it will be added to be able to apply network policy. So in this case, I have a team which defines a jobs policy, network policy, and allows the front end to talk to the back end. And under the hood in the IP, we use this identity to inject, and on the destination, obviously, we inspect that and drop and allow that traffic depending on the network policy. Also note that we can apply layer 7. So in this case, the get method on the default path is allowed. But for example, a put method on applicants directory isn't allowed. So we have a kind of API gateway features for layer 7 filtering, for doing microsegmentation and firewalling in the Kubernetes. Moving on to DNS-aware network policies, you can also apply rules on FQDNs. So, for example, this is very useful for external destinations of which the underlying IPs change, especially in cloud. For example, if you store, for example, contents, media, videos, image files in S3 buckets in Amazon, the underlying IP constantly changes because it's fronted with a load balancer. So managing IPs with that kind of resources is very difficult, and therefore we can support FQDN policies. So you can define rules, what specific FQDN is allowed, but we can also support regex, and in this case, wildcards as well. We've also introduced a new capability. If you add 2 stars in front of the dot, in this case, mydomain.io, it will automatically allow underlying domains as well. So www.mydomain.com. So that's also nice. And then you would typically define things like ports, protocols, and potentially layer 7 filtering as well. It's already time for the demo. How am I doing with time? Pretty good. Okay. So now I want to try to bring this all together. I've shared a lot of features and capabilities. And in the demo, I'm going to show step by step how this works. So before I start the demo, I need to do a little bit of explanation of the features we're using and the topology. So we're using, in this demo, Gateway API with automatically configured a load balancer. We will show the LB IPAM to allocate specific pools. I will show network policies in a different demo. That's unfortunately the case. BGP will be configured to automatically advertise those IPs. So as an introduction, as a platform engineer, let's suppose I want to host and configure a multi-tenant environment on Kubernetes. I want separation per team, per tenant, using IPs. I want to use unique ingress IPs per tenant. And I want to secure them using network policies as well. Then I want to use Gateway API to provide layer 7 routing and filtering capabilities, and automatically advertise the created load balancers to the network using BGP. This is the topology. So I'm using a container lab environment where I emulate a little spine leaf configuration with a top of rack 0 and a top of rack 1. And I have 2 nodes in each rack. And these nodes will be part of the Kubernetes cluster and will be used to set up BGP sessions with the top of racks. On the logical view, I'm creating 3 namespaces, let's say 3 teams, the blue team, the red team, the yellow team. Each team has their own namespace, has their own deployment, and we will configure a gateway per team. And the gateway will, under the hood, automatically configure a load balancer, which we will advertise using BGP on the network. Does that make sense so far? Good stuff. Okay, so now the action begins. Hopefully it works. I tested it yesterday. So, to start, let me go to the right directory. First of all, let me show that as it stands now, there are no established BGP sessions. Also on the network, I can see that the network is prepared to run or to receive BGP established sessions from the Kubernetes nodes, but I haven't configured it yet on Kubernetes. So as you can see, it's active, it's trying to establish, but I haven't configured the nodes yet. I've configured Cilium and I created free namespaces. So I'm using a lot of shortcuts. So bear with me. I'm doing kubectl get namespace. So I have already created the tenant blue, tenant yellow, tenant red namespaces. So that's good. That started. I already installed Cilium. So if I do kubectl get pods -a, I can see in the kube system namespace, Cilium is running. We have the operator running. We have Envoy running for all the layer 7 terminations. So that's done and settled. And I've enabled BGP in the configuration as well. Let me quickly show that. I have more than enough time. So this is my values file. I've enabled Gateway API. I have enabled BGP control plane. We have enabled enterprise features. So this is only valid for isovalent enterprise. IPAM mode Kubernetes. And I have enabled the kubeproxy replacement. This is important because this will ensure that we use eBPF for all east-west and north-south load balancing. And it's a requirement for Gateway API. This is all documented, by the way, so don't worry, you don't have to remember this. Now, let's say I want to start with setting up BGP. So therefore, I prepared a isovalent BGP cluster YAML file, and I will show how it looks like. Remember the 2 racks, 2 nodes per rack. So what I'm doing here, I create one BGP cluster config for rack 0. I'm selecting the nodes with matching labels, rack 0. And in this case, I define a BGP instance 65010 as autonomous system number for the nodes in that rack. And I'm peering with also ASN 65010 on one specific IP, one single top of rack in this case. Then from rack 1, similar, rack 1, only selecting nodes matching rack 1 to make sure they are only advertised with the top of rack in rack 1. In this case, a different autonomous system, 65011, is configured, and I'm pairing iBGP with the top of rack on 65011 on 10002. Then I'm referencing this peer config, and that's below here. So I'm putting 3 YAMLs in one that can also work. And this is a very simple one. I basically only specify the address families, and I say, please advertise BGP advertisements with the label BGP. And that brings me to the final one. This is actually that label. So this is the actual BGP advertisement resource. And in this case, I'm only announcing load balancer IPs of a given service with a given value. And in this case, I'm using an expression. So all load balancers matching red or blue or yellow labels will be advertised on the network. So now I can do kubectl apply -f and then this resource. Now actually Cilium will be configured to set up that BGP session, and we should see, if we do this, yes, so from the Cilium operational perspective, I have 4 nodes with a local AS, a peer address with established BGP, and I'm already receiving 9 prefixes, so I'm not yet advertising anything because we haven't configured anything. Then on the apologies. Then on the network, so this is, for example, top of rack 1, I can see now the session is established as well, but I'm not receiving prefixes yet. So in this case, 2 nodes with top of rack 1 and 2 nodes with top of rack 0. So now it's the time to make sure we can set up the load balancer IP address pools and the subsequent gateways for those teams to get the connectivity on the network. So let's start with the, let's say, blue. I define an IP pool for blue. In this case, I specify a CIDR block. So I have a /24 CIDR block for all the blue load balancers. And I'm selecting based on an expression labeled blue. So very simple, the operator will keep track of those resources. So let me apply this. And now it's time to create a gateway. So let me show the gateway. Gateway blue. This is a very simple example. I specify gateway for tenant blue in the namespace tenant blue. And here you see again that infrastructure labels, right? So I'm adding labels to the load balancers I create. Gateway class is Cilium. That enforces our product to use that gateway or configure that gateway. I create a listener, in this case on port 80, and I have a very simple HTTP route attached, which forwards, for example, /details to a specific service and the default value to another service with a specific method. I will not show this actual deployment in this demo, but you get what I'm configuring here, right? So let me configure this gateway, blue, keep track of what I'm doing. So if I now check the services, I can actually see the operator now has assigned, almost, I'm too quick, almost. Wait, did I apply the pool? I didn't, eh? Okay. Oops, there you go. Let me first, let's start over the gateway blue. Remove that. kubectl and fly. So the operator didn't have any IP to assign. Now I created the blue IP pool. Bear with me. Then apply the gateway. Now, yes, there we go. Now you can see it assigned 20.0.10.0 from that specific IP pool automatically. You see how quick this is? So if I deploy the gateway, it frees up the IP. It can allocate that IP to another load balancer again. Now, let's see what happens on BGP. So from Cilium's perspective, I now advertise that IP. And from the network perspective, I should be able to have that received. Yes, I received that prefix, but it should also show that in the BGP table. And as you can see, this is the top of rack 1 BGP table, and I can see I've learned routes through those nodes for this specific prefix. And as you can see, in this case, it's /32. If you enable aggregation, it will just advertise /24. But now the network has learned how to reach this load balancer based on the BGP advertisement. And if you would enable equal cost, then it would also spread traffic to those nodes. In this case, it's not. So who knows how this works with BGP? What decides which node will be selected? Quick quiz. What's the tiebreaker in BGP? The router ID. So the default router ID is the IP we configure on the node. So therefore, this one gets selected, and this is preferred, I would say, and this one will not receive traffic for now. But if you enable equal cost multipath, that would work. Let's, for the demo's purposes, also do this for the yellow and for the red tenants, because I have different selectors there to quickly show that as well. Let me show the red IP pool. In the red IP pool, I have a specific matching on label, not an expression. That works as well. So let me apply that before I forget. IP pool red. And the yellow has a namespace. Oh, the yellow has a namespace selector. As you can see here, that's also possible. So if you, depending on your operational model, depending on the requirements, you can have different selectors for IP addresses and IP pools. And again, different CIDR blocks for different IP pools. Let me apply this IP pool as well. IP pool yellow. Okay. Let's now apply a gateway. So the gateways are similar to the gateway I shown before, so I won't cover that again. So I have just the gateway yellow. It has the yellow label. Therefore, when I create the load balancers created automatically, it will pick up that label, and in this case selects 40.0.10, and for the red gateway, let's do that as well. Yeah, cool. Also configure. So now we have different IP addresses for different tenants, and let's show on the router. As you can see, we've learned those prefixes as well, and now the network knows how to route it automatically. This concludes this part of the demo, and I will also quickly show how you can observe traffic using our UI. So let's say you have those tenants running and you want to understand better from a operational perspective what's going on. We have also included a UI, so if you want to apply and observe traffic live, this is the view of the Hubble UI in a live demo environment. What you're looking at here is a namespace. So in this case, I hope it's readable on the back. In this case, we have a tenant jobs namespace, and we can see live traffic for all connectivity within that namespace. But as you may see, there's also external connectivity. So we see DNS traffic, 443 traffic, but also traffic on port 80 TCP to api.github.com. Maybe this is expected, as supposed to be and allowed, but it can also be something you need to react on, right? So if someone tries to exfiltrate data, or the application is accessing external resources you need to narrow down or to create policies for, you can use this UI to decide how you should define network policies. As you can see here, there's also an historical view. So this is the view in time, and you can actually narrow down to a specific window. It's not in this demo, but if I have a network policy update, it will appear as a dot on that graph, and you can see what has been created, updated, or deleted in terms of network policy. We also have a network policy editor built in, showing you the differences or what is actually created. So that helps you to also troubleshoot network policies in your environment. So, for example, if you see drops, you can see which policy is dropping that traffic. If you want to fine-tune a policy, you can see what you currently have applied, and you can edit in the UI what should be changed. However, it will not be applied immediately. And the reason for that is that our customers use typically DevOps, CI/CD pipelines to manage the life cycle of Kubernetes resources in production. So they would download it and apply it using a pull request in GitHub or other CI/CD resources before it's actually applied. Make sense? Okay, cool. I also want to highlight that we just released Splunk integration. So if you're a Splunk Observability Cloud user, we actually have out-of-the-box dashboards in Splunk. This is a dashboard showing, for example, policies. So as you can see, it's showing matching policies for ingress and egress traffic. But we also have high-level health policies, high-level health dashboard, so you can monitor what's if it's healthy. Oh, it's one cluster. Phew. Almost the demo is failing. There we go. Let's see. So I can see all the agents running. I can see the operators running. So I can monitor one or multiple clusters. In this example, we have a couple of clusters running, so I can monitor them accordingly. Also, layer 7 data is available, and also things like map health for BPF. At scale, big clusters. We had one customer 2 years ago who actually hit a limit for BPF in the terms of maps. So they should have monitored that through a dashboard so they could be alerted earlier that they would reach a certain threshold, and we fixed that by increasing that soft limit. So as an example, this is a dashboard for operating day 2 at scale and to troubleshoot perhaps latency, performance, and health of your cluster. And finally, we also have layer 7 dashboards in maybe I can show that using Hubble, which is our UI and metrics component. And this is more useful for, again, the application developer, right? So if he wants to troubleshoot how layer 7 is performing, what return codes are given, what latency and duration is from servers to servers, or ingress and egress is showing, we can monitor that through those dashboards. All right, so to conclude the session and then answer any questions, let's go back to the slides. Oh yeah, let me know. Did you like the demo? Did it make sense? Fantastic. Please leave your comments. And as a conclusion, you can see you can use features independently and together as a versatile Swiss Army knife across multiple environments. I didn't even talk about multi-cluster that can also be configured. You can use this across clusters, on-prem, in cloud. You can be flexible in how to combine them. You can tune those features for your enterprise environments, for their requirements. You can add security, you can add visibility, and we provide enterprise-grade security and compliancy for enterprise environments at scale. And it's also future-proof, because everything we do, we build on eBPF, and that's basically the future of networking. You may have heard of smart switches and Hypershield. Those are equipped with eBPF technology as well. Please complete sessions evaluations. I hope you liked the demo. Please give a good score. That would be much appreciated, but also please, if you think things can improve, let me know as well. I'm happy to be a better performer the next time. And feel free to continue your education. And finally, I also want to share some other Isovalent sessions. So if you want to learn more about eBPF, Isovalent, integration with other products, just scan the QR code to see what sessions are left for tomorrow. And also feel free to visit us at the AI Ready Data Center area on the show floor. We have 3 pods with my team and colleagues being present, and we're happy to do a demo, answer questions, book meetings, and to explain what we do else. So with that, thank you for attending. Thank you for being here up so late. Are there any questions I need to answer? Yes, please.
About the IPsec tunnels.
Yes. Thank you for the question. This is actually very good. IPsec, or encryption is just a single configuration flag in our product. You enable encryption and you choose IPsec or WireGuard, and from that point onwards, all pod-to-pod or node-to-node traffic is encrypted using eBPF. So you don't have to do anything else.
And it can be overlay in the routed environment, doesn't matter?
No, that doesn't matter. Yeah, so we either use VXLAN to have overlay connectivity between the nodes or direct routing. Yeah. Thank you. Any other questions in the back? Yeah.
So each node is advertising the gateway IP.
In this case, yes, in the demo. Yeah.
Assume I turn on ECMP and I have a single node failure.
Mm-hmm.
That does mean that all my existing connections are being broken because my hashing in the backend changes, right?
Yeah, that there could be some parts of those flows which need to retransmit or time out.
Do you have any solution for this problem?
Well, I think you can minimize that window by using BFD, for example. So you have the bidirectional failure detection, which is very quick. It's below seconds, so only a small part of that flow for that flows will be.
The problem still stays. Like you have 60
Yeah, that's true.
Okay.
Yeah, so that's definitely consideration. We cannot fix that on the routing side and in such a way. So part of the flows need to resend their traffic. Yeah, that's true. Yeah, good. Yeah. Any other questions, please?
In the DNS name and network policy example, I was wondering how often the IP address is evaluated.
Good question. Yeah.
Is it evaluated so based on the TTL of the DNS name, or how often is it?
Yeah. So very good question. Let me try to explain this as simple as possible. What happens is that we intercept that DNS request and response and record the IP, and we program the data plane with the allowed IP based on that FQDN. In our enterprise product, you can tune the timers. I think by default it has a TTL of keep me honest here, TTL of 60 seconds. So it updates every 60 seconds the IP. We have one customer who we need to tune this down for. They have different setting because this is a streaming media company, is super reliant on video and images on AWS, so they want to converge as quickly as possible. Plus, they have haven't shared that in this session, but we also have a high available DNS proxy, which makes sure that there's always an agent alongside Cilium running, which also keeps track of those IPs. That, in the sense that if either one of those fail, we still have the data plane allowing access to that content based on that IP. For them, it makes it powerful because they can do rolling upgrades live without interrupting traffic. So yeah, you can tune it, and by default, I think it's 60 seconds. Yeah.
And it's a default Cilium feature.
It's an isovalent feature, not in open source. So sorry. DNS-aware network policies are supported in open source, but you cannot tune it. In the networking project, you can tune it, you can get additional metrics, and you can have this HA component. So that's the extent of the differentiation between open source and enterprise. Actually, as a matter of fact, we have seen someone contributing to this. So it's an open source community, and I think it's coming in open source as well because someone is building it in the community edition. So yeah, I mean, that works. Yeah. Any other questions? Yes, please.
What other features are isovalent only?
We have specific events and alerts configuration for compliance reasons, exporting to Splunk Enterprise with alerts. The egress gateway HA I shown is isovalent only. Egress gateway is in open source, but not HA. All the BGP stuff is open source, except BFD, and I think except aggregation. We also have some, and this is beyond this session, we also have EVPN support just released, and we have some SIV6 capabilities. We've built that for a specific telco. That's also enterprise only. The UI I shown, there is a UI in open source, very basic. It doesn't include the network policy editor, doesn't include things like role-based access, so you can have rules who can see what. And it doesn't have this historical view I shown. That's also only enterprise. Any other questions?
For the ingress controller and the gateway API, can you actually do WAF and more advanced things?
So Gateway API is expanding its capabilities. So everything what is in a Gateway API, if it's released just now, you can expect it will be supported in the next release of Cilium. In terms of WAF, we have not yet built that. We have a partnership with different WAF companies, including Airlock in Switzerland, where we can redirect traffic to do the WAF filtering and give it back to Cilium on the data plane to forward it to the network. So WAF is, depending on what you need, limited at the moment. We're not having built WAF yet. We're considering it. We're getting more questions about this, but it's not yet there.
And do integration with ICAP servers for additional profiling?
That would be our runtime security product. We have our Tetragon product, isovalent runtime security. It's not the same as an what did you say? I capture or packet capture kind of what is.
It improves the WAF capabilities by checking malware to the files, doing an
Oh, okay. Sorry, I misunderstood.
gateway, schema validation,
Okay.
all of these other
Okay. No. No, that's not there. No. We can have filters on runtime security, so you can see what process, what arguments, what files are being accessed with what privileges. It's a different topic, but that's something we have network sensors for that as well, but not on that level, I would say. Any other questions? No? All right. So please feel free to pick up a free book about network policies, our HowUI, giving you some advice how to adopt that in practice. And I also like to extend, if you have nothing yet to do right now, we have a little event here across the street with beers and snacks and fun. So if you want to join us, feel free to join us. It's in the All Out. It's actually across the street here, somewhere upstairs. But you can also use the QR code to register. You can meet me and the team. You can network, mingle, get some beers and foods or other drinks, enjoy yourself, and and ask any further questions. So again, thank you all for being here. Have a great Cisco Live, and happy to answer any other questions later on WebEx or at the Mingle. Thank you.